Old model steamboats in poor condition. Part 3. Cleaning the engine using cellulose thinners in a well ventilated area. As this removes the oil, it is important to re-oil all the moving parts inside and out before test running the engine again. I perform a hydraulic test on the old boiler. After fitting blanking plugs into the boiler bushes, I describe the process in detail. The castings are not finished well on this at all, and the paint was just slapped onto the engine. Now it's time to put it in a bath of cellulose thinners, and please note I'm not dipping my hand in there, I'm using a paintbrush, and I'm removing all the paint and all the countless years of grime that are on the engine itself. A quick word about paintbrushes. This is a paintbrush that I bought as part of a set a while back, and it's diabolical. All the time it's dropping bristles, which doesn't matter with this job, but it would matter if you are painting with it. So I always recommend buying quality brushes for painting and crappy ones like this for just doing rudimentary jobs like removing grime from engines. A bit more work with the rubbish paintbrush, and as you can see, no attempt has been made on this engine to clean up the base casting, and the water pump part of the engine has just been soldered to this base, but it works, it's still there, and it's survived the test of time. In this close-up though, you can see that the general engineering is not perfect, but it's accurate. The person who built this engine really knew what they were doing. It wouldn't win any prizes for being elegant, but that's not the point. It just needs to propel the boat and work well. And it's also good to have this water pump fitted to the engine, so the engine can pump water into the boiler as it sails. I'm just checking for oil leaks, and no, there are no real oil leaks to speak of. But just to be on the safe side, I'll just take up any slack that I find on the steam chest covers. And there is a little bit, not much. I'll just take this opportunity to give some helpful advice. When tightening nuts that are this size, don't put a lot of pressure on them. They will just shear off, and then you have a problem. And look how slowly the engine will run. This is just because my air valve is leaky. I'm amazed at this. There's hardly any pressure there, but it's still enough to turn the engine over. Performing a hydraulic test on the old boiler. In the workshop I have a box full of blanking plugs, so it was a simple job to find blanking plugs to fit all these thread forms. I need to perform a hydraulic test on this boiler to make sure it's safe. If it fails the test, then it will be scrapped. If it doesn't fail the test, it will go back in the boat, where it will be used to provide the steam to run the engine. The silver soldering on this boiler is not the neatest that I've ever seen. But the good thing about the boiler is it has longitudinal stays. However, with a lot of old model steam boilers this is not the case, and some of them have brass end plates, which is no good at all. This one's copper all the way, and it looks quite strong. And just how strong the boiler is, I will find out shortly. So now it's time to fill the boiler, and I'm filling the boiler on a different part of the bench from where I'm doing the test. That's in case any water splashes onto the bench. At least I will know that it's not water that's come out of the boiler during the pressure test. At this point I would just like to say that it is absolutely vital, and I mean really seriously vital, that the water in the boiler goes all the way to the top. There must be no air in the boiler at all. The whole point of testing the boiler using hydraulics is the fact that water is not compressible. Air, of course, is compressible, and steam is very compressible too. So it would be really stupid to use air or steam to test a boiler for the first time. The most important thing is, as I start the hydraulic test, there must be no residual water anywhere on the boiler or around the boiler, and you're about to see why I'm filling the boiler on a different part of the bench. I've exaggerated the amount of water coming out to show you in the video. Here I'm putting the last blanking plug in place, and now this boiler is completely full of water with no air in there at all. I hold the boiler level as I screw the blanking plug in, and you'll see a little bit more water comes out of the union, which means that it's water all the way. Over now to the other side of the bench, being very careful not to spill any water, I fill the tank for the hydraulic pump. I cannot stress how important it is not to have any drops of water on the boiler or anywhere near the test area. In this clip I'm using a cloth to remove any water from the outside of the boiler. And here I've connected the pipe to the boiler, so now I just pump the handle and you'll see the pressure rise. The idea of this is to test the boiler to twice working pressure, and its working pressure is going to be 60 pounds per square inch, but I'm going to take it up as though it was 80 pounds per square inch to around 160 psi. By the way, I referred to the pump as a hydraulic pump. It is of course a tender hand pump. But it's still a hydraulic pump because it pumps water, and in no time at all the pressure has reached 160 pounds per square inch. I'm now going to leave the boiler at this pressure for about 15 minutes. What I should really do is fit a valve on the boiler so I can cap off the pressure, because there is a slight leakage back through the ball valves on the pump. After 15 minutes, I think it was a bit longer than that in this case because the phone rang, I have to remove the blanking plugs. There's no danger whatsoever in doing this because even though there's a lot of pressure in the boiler, it's only water. So I very slowly undo the plug and you can see the water starting to come out and you can see the pressure dropping. Yes, I get a lot of water squirting at me and running onto the bench, but that's really not a problem, is it? If the boiler was full of compressed air or even worse, steam, there is no way I would be doing this. So I'm pleased to say that this boiler is past fit for service, so it's time to fit the fittings. This is a clack valve and this is the water gauge going in. Along with the fitting of boiler fittings, I always use Loctite 542 and I'm putting a very tiny amount on this top nut because it's very annoying if after you get your boiler in steam, water starts pouring out of the top nut. And similarly, I've put some Loctite 542 on the steam tap. All I have to do now is tighten it in position, and there we go. The next fitting to go in is for the pressure gauge, and this thread is a 1/4x32. But luckily, I had a 1/4x32 double union adapter in my box of 1/4x32 double union adapters. And to this union will be connected the pressure gauge, but not directly. It's always important to use a siphon, which is just a piece of copper pipe, and that stops the steam from getting to the internal parts of the pressure gauge, which would damage some of the internal components. And that's just about it for now. In the next episode, I will give the boiler a steam test, but before I do that, I'll fit the pressure gauge and a brand new pop-type safety valve. The one that I'm just removing was just fitted for effect, and it doesn't work properly anyway. As I mentioned in the last episode, if you want to see more about this, watch the full series. It's called A Model Steamboat Named Edith. That's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.